Alright, this video is on using the distributive property. So to go ahead and get your notes page set up, put your title up at the top, the distributive property lesson, and then we want to list our learning standard here. For this one it's 6EE3, apply the properties of operations to generate equivalent expressions. An equivalent expression are two expressions that are equal to each other. They may be written differently or they may be organized a little differently, but you're going to get the same answer. So our I can statement is I can write an equivalent expression using the distributive property. We want to be able to say yes to that when we're all done today. So go ahead and get that filled in and then we'll get started with the lesson. So let's start with our definition, the distributive property. It's a combination of multiplication and addition. And then here in purple is the big piece. Here's how you tackle the problem. We're going to multiply the number on the outside. So you'll see 4s on the outside of the parentheses here. Remember, when 4 is right next to the parentheses, it means you're multiplying. So you're going to multiply the number on the outside times each of the numbers on the inside. So in this case, we're going to do 4 times 20 and 4 times 8. And then when we're all finished, we're going to add those pieces together. Okay? Sounds a little complicated to get started with, but once you see a couple problems in action, you'll realize it's not quite so bad. You'll notice in the background, I kind of have some rainbows in the back there. That's not there just to be cute. A good way of thinking of the distributive property, or in remembering how to do the distributive property, is to think of it like a rainbow. Sometimes I call it the rainbow method. But what it means is, instead of following our normal order of operations, instead of doing inside the parentheses first, then multiplying times the number on the outside, we're going to change it up. And the reason we're going to do this is to make life a little bit easier for ourselves. We're going to rewrite it in a new form that'll help us in finding our answer. If we were to just go ahead and do this problem, we would do 20 plus 8 is 28. Then we'd multiply times 4. We'd probably have to write off a little multiplication problem off to the side in order to find our answer. Not the end of the world, but we want to try to make life a little simpler. So we're going to use the distributive property. We're going to take the 4 and we're going to multiply it times the 20. And we always need to write out these steps. Then we're going to do 4 times the 8. So we're just taking the 4 times each of the pieces on the inside, and then we're going to add them back together. Now we go ahead and we do the multiplication. In this case, the idea is that the multiplication is actually easier, something that we can do mentally. 4 times 20 is 80. 4 times 8 is 32. Add them together and we get 112. That's the same answer we would have gotten if we had done 20 plus 8 is 28, and then multiply times 4. Here we can double check our work. 8 times 4 is 32. 8 times 2, or 4 times 2 is 8, plus 3 is 11. So it's not changing what we're getting for an answer. It's just changing how we write out the expression in the hopes of making life a little bit easier. Here's where we're really going with it. The distributive property is the most useful when it comes to problems involving variables, because we can't just add it together like 20 plus 8. In this case, 3x and 7, you can't combine those two terms together. And we're going to talk about that a little bit later this week. When one term has a variable in it and the other one doesn't, you can't combine those two things together. But we want to be able to rewrite this expression a little bit, so we use the distributive property. We take the 5 on the outside and we're going to multiply it times each of the numbers on the inside. Hence the name the rainbow method. You kind of draw little rainbows to each number, and that helps remind you that you're going to multiply times each of them. So in showing our work, we show that we did 5 times 3x plus 5 times 7. Then we go ahead and we do our multiplying. 5 times 3x is 15x. 5 times 7 is 35. In this case, that's actually our final answer. We can't combine together that term that has an x with the plain old number. So that's our final answer, but we were able to rewrite it so we didn't need those parentheses anymore. We were able to simplify it and still have the same value there. So let's try a couple here. Hopefully you put those last couple examples in your notes, and let's put these next couple. Here's what I was talking about before. Sometimes the goal of one of these problems is to make the math so easy you can do the math in your head instead of having to do an ugly multiplication problem. So we're going to break these problems down so we can use our distributive property. Right now we have 6 times 36. I don't really know what I'm going to get when I multiply times 36, but 36 is really 30 plus 6. I just break it into 2 pieces. Those I can multiply times 6. So this is a case where I can use my distributive property. I'm going to take the 6 times each of the pieces. So 6 times 30, 6 times 6. As you're practicing it, we need to see you write out each of the steps. So don't just skip ahead and tell me what you get when you multiply. Show me what you were actually multiplying. Once you've shown me that, once you've rewritten it using the distributive property, now we can go ahead and solve it. 6 times 30 is 180. 6 times 6 is 36. These are just 2 regular numbers, so we can add them together. So we get 216 for our answer. So that's how we use the distributive property to rewrite our problem. Same thing here. 8 times 7 1/2. Normally, we'd have to turn the 7 1/2 into an improper fraction, and then turn the 8 into into a fraction, and then we'd have to multiply them together and do all that simplifying. But if we think of 7 1/2 as the same thing as 7 plus 1/2, basically just kind of pulling the pieces apart, we can take that and multiply it times 8. I know how to do 8 times 7. And I don't know how to do 8 times 1/2. I'm going to do it as 2 simple, smaller problems, and then I'll put it back together when I'm all done. 8 times 7 is 56. 8 times 1/2, well, that's really 8 over 1 times 1/2, which is 8 halves. Remember, just multiply your numerators together, multiply your denominators. 8 halves simplifies to be 4. So 8 times 1/2 is 4. 56 plus 4 is 60. There's my answer. No improper fractions, no fancy work. Once you get good at the distributive property, you'll be able to even do it in your head without having to write everything out. For now, you got to write it all out. We want to be able to see that you know how to work through the problem, but eventually you get to where you can use this to make problems into a mental math problem. All right, here's where we really need it. Using it when we're doing our expressions involving variables. Right now, I have 8 times, and then in parentheses, x plus 3. We can't combine x and 3 together. One's got a variable, one doesn't. But I really don't like to have expressions that have parentheses in them. I like to simplify things a little bit, and the distributive property lets me do that. Instead of having to worry about what x plus 3 is, I can simply distribute my 8 through to each of those pieces. So I'm going to do 8 times x, and then I'm going to do 8 times 3. I'm going to multiply that number on the outside times each of the pieces on the inside. 8 times x is 8x. 8 times 3 is 24. Again, when one term has a variable and one doesn't, we can't combine those together. We say they're not like terms. So that's actually as far as we can go. 8x plus 24. If you think you've got the idea down, go ahead and try this next one on your own. If you're not quite sure, follow along with me as I try it. So again, we're going to distribute this 5 because it's really being multiplied times what's inside the inside the parentheses. So we're going to do 5 times 9 and 5 times y. 5 times 9 plus 5 times y. The easiest thing to forget in these problems is to forget to multiply the 5 times the second number. That's why drawing in those rainbows helps. It reminds you that you need to do it for both numbers in the problem, or both terms inside the parentheses. 5 times 9 is 45. 5 times y is 5y. Again, one term has a variable, one doesn't, so we can't combine them together. So we just leave it as 45 plus 5y.